advanced NMap techniques with this time on Hak5. Hello everyone, welcome to this episode of Hak5. My name is Shannon Morse, and this is your weekly dose of Technolust. And this week, again, I have Dan Tentler visiting. Again, his name is Vis on the Twitterverse. You may have heard of him before.
Hello, Internet. I'm here to trouble you further.
So Vis, if you didn't watch the previous episode, which you should, he does a whole bunch of really cool offensive security for his company, which is called Phobos.io. And today he is here to teach us all about these crazy cool advanced NMap techniques. Most notably, I wanted to learn about these because I've done a whole bunch of NMap series and tutorials and episodes on Hak5, but I've never really delved into all the really advanced stuff that you can do. And you can actually get pretty down and dirty with NMap, wouldn't you say? Yeah,
you can make a lot of noise with the thing. It'll scale to a certain size, but at a certain level, you have to start including multiple threads or different tools, or you have to start scaling, with a lot of other technologies, like
scaling.
Scanning does require scaling at some point. You can't just do everything with a single NMap thread. Yeah,
so NMap in itself is a pretty simple tool to use, and while it does have some scalability, you're going to show us some of those extra tools that you can use with it, right?
Yeah.
Okay, so let's go ahead and get started into some demos.
Certainly.
Yay.
Yeah. So. A great starter would be to compare Mass Scan against NMap and see what these things are good at and what these things are not so good at.
Yeah.
So the way that I have described them together in the past is Mass Scan is kind of like a flamethrower and NMap is a scalpel. And there's not a lot that exists in between. So like to fill the gap between a flamethrower and a scalpel, you have to either figure out a way to pare down the flamethrower to where it's just a teeny flamethrower, or like a bunch of really angry candles. Or a whole bunch of, like, a bushel of scalpels.
Bushels.
Yeah.
So without knowing exactly what Mass Scan is, I think I can define it based on the terminology. And it sounds like via the flamethrower definition that it goes out there and it scans a ton of areas, a ton of different addresses to find whatever you're looking for, while NMap is very directed, very precise in what it's looking for. Is that right?
More or less. So the thing that Mass Scan does that makes it interesting is it does what's called asynchronous TCP scanning. So you're familiar with the TCP handshake?
Yeah.
SYN, ACK, that sort of thing.
Yeah, of course.
That all takes time. And there are built-in timeouts in scanners like NMap to say, I'm going to send a SYN packet and wait for an ACK, and then I'm going to send a SYN ACK, and then there's timings, and then they measure how those timings work, and then they adjust the speed of the scan based on that. It's all really intricate, and there's a lot of math involved. Fine, that's great. The trouble is if you need to scan 16 million hosts, that takes a lot of time and creates a lot of overhead. If you're like, all right, I need to scan a /8, 16.77 million hosts.
That's a lot.
Yeah, if you want to scan an entire /8, NMap probably isn't the right tool for the job.
Yeah.
It also depends on what your objective is. So for example, in my dealings on the internets, I have done a bunch of scanning. Last year, I was scanning for Eternal Blue and Double Pulsar because that was like the thing. When the NSA leaks happened and the Fuzzbunch and Danderspritz tools got leaked, myself and several other folks got together and did a whole bunch of research and figured out how they work and how to deploy them and how to run them, and that was a really neat learning experience.
Yeah.
During that process, we thought, wait, if ostensibly every single Windows host connected to the internet is possibly vulnerable to this, how many have already been infected? Because like shadow brokers leaked this stuff like today or whatever. How long have they had it and who have they shared it with before they made it public?
So it's entirely possible that it could have affected millions upon millions of addresses online.
Oh, it did.
Oh.
Yeah.
Wow.
Oh yeah, if you go on the Twitters far back enough, you can find pictures that I posted to Twitter of my scan results, how I did the scans. That I was doing a play-by-play. I was just putting it on the internet, and
that's scary.
It got a lot of very interesting press. And the idea was like, so there was 4.5 million hosts listening to the internet listening on port 445 that were connected to the internet. Of that 4.5 million hosts, it was several hundred thousand that had. Oh man, I'm gonna misquote myself. It was some ridiculous number. It was like
It's okay. It was a long time ago.
4.5 million hosts exposed, and of those hosts, that was a mishmash of everything that listens on 445. So not all of that was SMB. Some people run SSH on 445. Some people have a web server on 445. Like, who knows? There's a bunch of other machines on the internet that I know Checkpoint is guilty of this as a defensive mechanism, and I think this is silly. They put SYN cookies into the Linux kernel for a reason, which is like the neckbeards will get me on this one.
Yeah.
But SYN cookies were put into the Linux kernel to prevent SYN flooding.
Okay.
Well, a bunch of next generation firewall vendors decided, you know what we should do? We should have a firewall just listen on all ports all the time, even if they're not doing anything, just to confuse people with port scanners.
Oh.
And I'm like, okay, well, mass scan. And they're like, okay, what about that? I'm like, well, I'm going to fill your connection pool.
Yeah.
Like forever. I'm going to pin your firewall against the wall.
Oh, no.
And you're going to have a $250,000 paperweight.
Oh, no.
And yeah, you can do that. We've done load testing. Like we've had customers,
hilarious.
Phobos have asked us to do a shootout between two firewall brands, and we were able to, with this laptop, this dinky little underpowered laptop, send 30 megs a second of just SYN flooding at a firewall and have it just CPUs go to 100. Yep.
That's ridiculous.
Yeah, and it's because they're like, oh, well, we should listen on all ports because that'll confuse scanners. I'm like, well, yeah, scanners have outgrown that, and now that's no longer a clever thing you can do to confuse scanners. Now you're going to hurt your customers. But so there's somewhere between 800,000 and 1.2 million of those on the internet.
Wow.
So when you get a result that says 4.5 million computers on the internet are listening on port 445, that number is fuzzy.
Yeah.
So it also changes second to second, right? So like how many DHCP-based ISPs are there in the world? If you do a scan now and then count to 10 and do another scan, you're going to have several 100,000 machines disappear and reappear because their DHCP leases will expire and renew, and they'll be on a different IP 10 seconds from now. When you're talking about the globe at scale, the entire IPv4 internet across the planet. Which is a bizarre thing to like say, here, let's scan the whole internet.
Yeah, totally.
You can do it. There's just some prerequisites.
It'll just take a while.
45 minutes on one port.
45, wow.
Yeah, you have to have, I have a box and a colo, an actual physical computer, not you can't do this on Amazon or DigitalOcean or Linode or whatever. Like, you can't do this in what we call multi-tenancy environments. You can't do this in an environment where like you have a tiny little VM inside of this big server, and this big server has like 5 or 6 maybe 10, who knows, Ethernet interfaces that go to the internet. You're going to saturate that backplane, and nobody else is going to be able to use it. And everyone that's on that shared host is going to get real pissed because their network will have gone away because you're abusing it all. And then
don't do that.
Very, very quickly, you will find that your cloud provider hates you and your account is now gone.
I feel like this is a personal story.
Not from me, thankfully.
Oh, okay.
But I have had other people that have asked me, oh, I want to do this thing. How do I do this thing? And I explain to them how to do the thing, and then 3 hours later, they come back to me and say, DigitalOcean banned me. I'm like, yeah, that's because you did something really dumb.
Oh, no.
Well...
So don't do that.
Yeah, just don't, like, be a friendly neighbor on the internet. Don't, if you're going to scan the internet, that's cool, but don't do it in a way that's going to, like, wreck things for people, because they're going to get angry at you, and they will find you, because they own the hardware.
Yeah.
My suggestion is just, if you're serious about it, spend the money, put a piece of equipment in a co-location facility, and get at least a 1 gig uplink to the internet. In that circumstance, if you have equipment in a data center, that data center, like the one I'm in, I think it has 30 gigs a second to the internet.
Wow.
And my link is only 1.
Wow.
So there's no way that I can interfere with the global operations of that data center because my machine is only physically capable of sending packets a gigasecond.
That's nice.
Yeah, so there are some considerations, but when you get all those out of the way, TLDR, it's a lot of fun, interesting stuff. But back to, you have a flamethrower in one hand, you have a scalpel in the other, like how do you get in between?
Yeah.
So let's just say that we are looking for, let's do port 445.
Okay.
Just for grins.
Yeah.
So we want to scan all of, we want to scan the entire internet on 445. So let's do mass scan. Right, so it's already in my buffer. So mass scan 0000, port 445, rate, what's that, 1 million packets a second?
1 million? I think it is.
10.0.0/8 because that's non-routable. We don't want to scan 192.168.0.0/16 because that's non-routable. We don't want to scan.
So you're making your exclusions right
172.16.0.0.12. Yeah, these are all non-routable internal networks, so there's no sense in wasting the traffic to send to them.
Yeah.
So we do that, and let's see if we can do mass scan rate, and then what's it? exclude, is it exclude.txt? Excluding 20 ranges for, yeah, so here
nice,
we go.
It worked. Cool.
So you can just see it scrolling like mad, right? All right, so that's fun. We're spraying the internet. Way.
Yay,
so
fun.
If we do, actually I think there's an exclude already built because it said that it was exclude. So if we do -ox, like it takes the same syntax as Nmap. So we're gonna output to XML and say Hak5-445.txt, and we get a different result. So now we're seeing that we're sending 488,000 packets a second. It's going to take, the time is going to fluctuate quite a lot.
Yeah, of course.
But it says it's going to take 2 hours and 11 minutes to complete the scan of the internet.
It's a pretty long time.
Like if we hit Control-C, it'll wait. So what it does is wait for a second. It waits for a second. Because the way that this tool operates is that it does asynchronous TCP scanning.
Yeah.
That means it sprays the internet with SYN packets and then only pays attention to the ACKs that come back. So it's not instantiating a TCP session.
Yeah.
It's like faking it.
Yeah.
It's like twiddling ports to see which ones are alive. And if it's alive, then we get
that makes sense. So you don't get inundated with information that you don't need.
Hey, look at that. So it's XML based.
Wow.
It's like the results look exactly the same as Nmap XML. So you could take this and import it into any tool that will operate on this. If you're clever enough with XML, you can write a parser to tear this out.
Yep.
I am not. I actually cut on the quotes, and I'll say take column 4. So I can say like.
So just for the address.
Cat Hak5, yeah. Cut dash D quote dash field 4. Is that right? Yeah. So field 4 is the address. Great.
Nice.
So
okay,
like
cool. If y'all watched my
WC-L.
recent hack tip, you know all about cut.
So I did that in just a few seconds. There's
Awesome.
12,290 hosts that have 445 open. I have no idea what's running on 445.
Yeah,
we don't know. All we know is that the port is open. And it could even be like the firewalls I mentioned that are like faking it, like there's actually nothing there and they're just doing what's called tar pitting.
Right. Yeah.
Yeah, so there's that. So how do you take this and how do you do something interesting with it? Like let's say, hypothetically speaking, so let's say hypothetically speaking, who can we scan on the internet without fear of reprisal?
One of our favorite countries.
Sure. Well, I'm fairly certain that I can get away with scanning China and getting away with it because it's China. I went on Shodan and found a random host in China, then did a whois lookup on the IP. It gave me a range, and I used IP Calc.
Okay.
Actually, I'll just show you the command. So IP Calc on this range gives me 122.64.0.0/11.
Oh, cool.
So /11 is big. So if we do IP Calc this /11, how many hosts are in a /11? 2 million.
Whoa.
2,097,150 hosts.
Jeez.
So that's a big.
That's a lot.
That's a lot, yeah.
Yeah,
So
that looks like too much work.
if you try to Nmap this, I'll show you like base Nmap commands.
Yeah, totally.
So Nmap that, Nmap that, TCP, give me banners,
Yeah.
don't ping, no trace route, verbose, send 5,000 packets a second minimum, min host group is work on this many hosts at a time, and we'll say 256. And then min parallelism is again 256. Min parallelism is used to define how many NSE scripts you run at once.
Oh, okay.
And the idea is that this box is a box I have in a colo, and it is beefy, and it can deal with this. It's attached to a gig link. I'm going to be upgrading to 10 gig a second soon. And when that happens, this is going to get even more ridiculous.
Wow.
And the idea is, okay, so we're going to run Nmap against a /11, and I'll just let it go for a minute or two. And I'm not even scanning on all ports. I'm scanning on just the 1,000 default. So you can see how it keeps saying, dropped to increase, dropped to this. What it's doing is it's trying to transmit packets from my box in the data center to China.
Yeah.
And not all these hosts are responsive. Not all these hosts are going to be alive. And what's happening is it is attempting to do a full TCP handshake, and that's causing a lot of overhead.
Yeah.
Like a lot of overhead. So if I wanted to do the same thing with mass scan, because this will take forever. So you hit enter and it tells you like, right, so you hit enter and here it says, so such and such, 21.82% done, estimated time of completion, 3 minutes, 2 minutes, 27 seconds remaining. Well, that's for only the first 256.
Okay.
So if I take a /11, how many /11s, or I'm sorry, how many blocks of 256, which this is a /24, how many /24s exist inside of a /11?
24 is inside of a math.
Subnetting, networking. Like if you tried to take the CCNA in the 90s, they made you learn how to do this stuff.
Yeah.
If you were a network engineer, you had to learn how to do this stuff. If you're a sysadmin, sometimes right. Back to the theme of if you did some stuff in your past, like this stuff becomes easier.
Yeah.
Yeah. So there's a Python script that a buddy of mine wrote that I've slightly augmented. He calls it TNMap. So we'll do vi TNMap. And we'll change this prefix length to /24. And what that will do is
24.
Yeah, exactly. So /24 is because there's it's called a 24-bit subnet mask. And in this script, what we can see is really short and sweet. It basically takes input of a large subnet mask. In this case, we're going to use a /11.
Okay.
So take a /11 and you give it to the script, and this indicator here says, take this /11 and slice it up into however many /24s exist inside of a /11.
Okay.
So now that we've changed that, we can say Python TNMap that /11, and then it will scroll. And the idea is what it's done here.
Wow, that was fast.
I controlled C, but
okay.
it's specifying scan speed, only open ports, TCP, no DNS and no trace route, super verbose, minimum rate of 1,000 packets a second, scan 128 IPs a second. I need to change that to 256. Max retries 2. SC is use script defaults. PN is I need it to be lowercase, but no ping.
Okay.
Output to this file, and then this subnet.
Oh wow.
256.
So why do you want it at 256 as opposed to 128?
Because the subnet mask, a /24, a /24 has 256 hosts in it. Or 254
so you want
hosts.
to hit all of those 256.
Well, that's the idea. So what we've done is we've started out with this gigantic subnet, a /11.
Yeah. And
the /11 has like 2 million and some change hosts in it. We can't tell NMap to scan all 2 million at the same time. It won't work. It'll barf.
Yeah.
Or your system will run out of RAM, or there's a bunch of other problems you can run into. But you can slice it up into little pieces. And what the intention here is, you're going to be post-processing the results, right? And you're not going to scan something this big and eyeball the results by hand. You're going to take however many.
You would probably take it all and put it into some kind of document where you could splice it out, splice out the information that you're looking for.
So let's check. Okay, so what this tells me is, if I've taken this /11 and divided it up into /24s, there are 8,192 /24s.
Still a lot.
So 256 times 8,192.
Jeez.
Right, we're getting into stupid math at this point. And it gets bigger from here. This is just a /11.
That's ridiculous.
Yeah, so when you get to whole internet, I think the whole internet is 4.4 or 4.45 billion.
Wow.
Yeah, it's so orders of magnitude larger than what we're dealing with here. But even still, these numbers, scanning over the internet, trying to, like if you're dealing with a very, very large organization, or you're just doing research, these are the sorts of hurdles you're going to run into. So the idea here is this script will take the input of the initial CIDR mask, the /11, and convert it into a whole bunch of /24s. And what this does is it converts it into an NMap command line. And you're thinking, okay, well now I have 8,192 individual NMap command lines.
Yeah.
Now what?
What do you do with the information now that you've gained it?
Well, since, remember, flamethrower on one hand, scalpel on the other, we need something in between.
Yeah.
I'm making a bushel of scalpels.
So you're using, what, a bunch of NMaps?
Yeah. What I'm going to do is I'm going to use a command line tool called xargs.
Oh, xargs. I've heard of that one.
Yep. xargs.
Still one I need to study up on.
Yeah, xargs is really cool. So you can say, take this, and instead of sending the output to word count and give me a line count, do xargs, is it slash, well, I is cmd, and then I think it's slash x. Let's do 100. Oh, actually, I need to make a directory first. Make dir out. because this output specifies the directory of out.
Okay.
So I need to have a place to put, because what this is going to do is it's going to generate 8,192 XML files, and each XML file will, each XML file will be the result of one of these scans.
Wow.
And then at that point, now I have this gigantic pile of XML. I have to import that into some tool for processing.
Yeah, of course.
So this is just the first step. This is like doing the initial sweeps.
Okay.
And then when you're done with the sweeps, then you can go and analyze the resulting data and decide if there's interesting stuff.
Okay. So let's do that.
Domain.com has all your website needs, from .com and .net domains to intuitive website builders, so you can take that first step in creating your online identity. Let me tell you, there's no domain extension like a .com or a .net, or if you want to brand yourself, Domain.com has over 300 domain extensions like .club and .space. These guys are huge fans of Hak5. They're affordable, reliable. We've been using them for years. They've got all the tools you need to share your ideas with the world. And because they're such big fans, they are hooking you up with 15% off their already affordable prices. So get domain names and web hosting and email, and just be sure to use that coupon code HAK5. So when you think domain names, think domain.com.
So what I've done is I've modified the TNMap script to basically only give me...
You commented out everything.
Yeah, I commented out the NMap command line so that all this script does is give us just the subnets instead of the actual NMap command line, because that seems to behave better with xargs.
Okay.
If we run this xarg command, it's complicated, right? So what we're doing is we're running Python, we're running tnmap.py, and we're giving it a /11, and the output of that /11 is 8,192 individual lines. Each line is a /24.
Yeah.
And what we're telling xargs to do is take -i, take the string CMD and make that like a variable that is full of the result of each one of the, right? So what I'm doing is xargs is going to take every line that comes out of this first Python command, and it's going to say, take the output of this first Python command, stick it in the variable CMD, allow up to 100 processes. This -P100 says run up to 100 processes. Here is a command line for NMap, and then this CMD here is going to be populated with the output of this command.
Okay.
And so what we're doing is we're creating, in a single line of bash, 100 threads of NMap reading from designated input of this /11.
Okay.
So if we just run this, we just start getting like...
That's a lot of information.
It's just ridiculous scrolling XML.
Oh, wow.
And what's happening here is you're getting the standard out of every... you're getting the standard out of 100 threads of NMap.
Wow.
So one of the things you can do to check this out, to see what it's doing on the back end, to make sure clear. Make sure that is that set to PN? No, it's not. Let's do that real quick. -PN. There. So it should be a little bit different now, because it's not going to actually send pings. It's going to actually just try and you're not going to see ping times and stuff. But so this is 100 threads of NMap, all trying to start at once.
Okay.
If you're familiar with Byobu, you're familiar with tmux or tmux or screen? Okay. So screen and tmux are tools that you can use to maintain the continuity of your shell in case you're disconnected from your host. So
that's cool.
If you're connected to a host and you're not inside of screen or tmux, I like Byobu because it has the most features.
Byobu?
B-Y-O-B-U, Byobu, yeah.
Byobu, okay.
And I use it all the time for stuff. And one of the things that it does that's really, really cool is inside of one SSH terminal, I'm going to show you a trick. It functions the same way screen does, Control-A being your control character. You Control-A and then pipe, Control-A, pipe. You can have a new shell, Control-A tab, Control-A tab, and now I have sort of two shells in one.
That's cool.
So what I can do here is run a tool. Let's do this.
How did I not know this exists? That's awesome. That's so useful.
You've never been sat on the floor of a data center for like 36 hours straight.
I guess so.
Yeah. And the cool part is this will stay this way if I disconnect. And if I reconnect, I still get my cool split screen. So the
really
split screen in one window, this is really, really neat. And it can get really stupid. You can Control-A% and you can split it vertically. Yeah, so you can do a bunch of the stuff. But for our purposes, I'm going to be running nload. And nload is a very cool application that is a command line bandwidth
that's neat.
graph.
Okay.
So now, if I'm running my bandwidth graph on the bottom, and I do my nmapping again,
oh wow,
you can see
look at that jump.
It starts to jump a little bit,
Yeah.
but it hasn't gotten into the meat of things quite yet. It's
Right,
still
yeah.
doing some scans, but when it starts to detect stuff, you can see, oh, now it's
Yeah.
going to 1.45 megabytes. This is still like nothing. This is children's play.
Yeah, of course.
Let me tweak the scan a little bit more and add some more stuff, like
Okay.
min packet rate. Min rate, call it 1000.
Oh wow.
Min host group. Host group
I know my eyes are so bad for it.
256.
So hard to stare at a screen.
Yeah, I also have trouble with reading comprehension. Min rate 1000, min host group 256.
Okay.
Min parallelism. That's min parallelism.
Parallelism.
Yeah, min parallelism is the argument that defines how many NSE scripts to run at a time.
Oh wow.
And you can run lots, but the thing is, the more you run, the more sort of frayed around the edges your scan will get. If you want like a little scan that's super precise and doesn't miss anything, then you want to go kind of low and slow.
Okay.
But if you want to just spray the internet and catch stuff, you're going to miss packets. You're going to get
Yeah.
packets that are dropped and things like that,
Yeah,
which is
of
why we do the big stuff is what we do. That's what mass scan is for. And then when we want to refine what we've found, like think of it like you're mining. You're mining for gold.
Yeah.
You're going and you're tearing rock out of the earth, and you have these huge things of rock. There's probably this much gold in there,
Right,
but
of
you got to
course.
deal with all that rock, and
Yeah.
you got to separate the stuff you want from the stuff you
Yeah.
don't want. And what mass scan does for us is like we're going to scan 2 million IP addresses. Which ones are alive? Which ones are not alive? Well, we only care about the ones that are alive.
But you have to scan everything to
Yeah,
find those.
exactly. You have to scan everything to find out.
Yeah.
So in this case, what we're going to see is the last scan that I ran, like the outbound traffic was like what, a megasecond,
Yeah.
megabit, not even a megabyte. Well, that's still nothing. It hasn't really started yet. There we go.
Oh.
7, 12,
Whoa.
18, 28, 39, 95.
Oh wow.
Yeah.
That's so cool.
There you go. Over 100 megabit a second. So I am now scanning China
Nice.
at 107 megabit a second. And this is still nothing. Like I can go to probably
fast, though.
probably 800. It is, but the thing is, the higher you go, the more you introduce jitter and
Yeah.
network discrepancies and things like that.
Yeah.
And like you're gonna, yeah. So now, see, NMap is now complaining RTT var has grown to over 2.3 seconds, which means hosts are now. See, you can see it's. So if we scroll up a bit, you can see. RTT var has grown to
Whoa.
over 2.3 seconds, decreasing to. See, what this is NMap
Yeah.
seeing that the scan is getting slow and
Yeah,
latent,
yeah.
and it is adjusting itself to try and deal.
Dude, that's cool.
So if we do the
All
same,
things I didn't know you could do.
yeah. Well, these are the things you do at 2 in the morning when you're bored.
I guess so. I don't know.
Wait, let me rephrase. These are the things you should be doing at 2 in the morning when you're bored.
Should be?
Yeah. Who else is going to do
I
it? if we're
should
not
be
gonna?
sleeping at
No.
2 in the morning.
No.
Sorry, I'm
So-
not a night owl like you are.
So let's do mass scan again, except what we'll do is we'll plug in our /11,
Okay.
and we're only going to scan on port 445.
Right.
And let me make this.
Are you
I'll
keeping?
bump that
oh,
to 2
okay.
minutes. Just I
Oh,
can't
you're gonna
transmit.
bump it up.
I can't transmit that fast.
Yeah.
But what this is going to do is it's going to top out the network's ability to deal with it. So we're
Gotcha.
just going to do that.
Okay, so
and-
it'll still run. It'll just max
So-
out. Oh.
I did all of them. Okay. Cool. Well, that was just one port. Okay, so that was one port. Let's do.
What if you do more ports?
Let's do all the ports from 1 to 1024.
Yeah.
This should take considerably longer.
Oh, look at that.
So now it's saying an hour and a half, an hour. Yeah, an hour and 15 minutes to
Okay.
scan this /11. Its output traffic is 243 megabit a second of just scan traffic, just NMap. Oh, I'm sorry, just mass scan rather.
Yeah, yeah.
So the idea here is this is going to tell us what's up and what's not up, and then what we can
Okay.
do is we can take that last script that we were using, and we can incorporate one into the other and say, well, when we get the results
That's really
of this,
cool.
yeah.
It's so beautiful.
Well, it gets more interesting. Check it out. I'll
it
show you
looks
another
like a
thing.
unicorn.
So we'll do the same thing with TNMap and NMap, and we'll just do the same thing with NMap, right? So NMap versus Mass Scan.
Okay.
So one version or one copy of NMap versus 100 threads. I'm sorry, 100 threads of NMap versus one thread of Mass Scan, and it's half, less than half.
Yeah.
Which is an interesting thing to consider. So if we get back to this thing and we kill that, let's do htop. And
good old htop.
And now you can see, like, look at all these
amazing.
nmaps.
Wow.
Look at all those nmaps running, right? So it's all my machine is pegged, completely pegged.
Yeah, totally.
And then we do like psaux grep nmap, and it's just like.
Wow.
So then we can say wc-l, and we're running, well, let's do grep-v grep. 102 instances that contain nmap. So the idea here is nmap only scales so large, but we can use literally a bash one-liner. If the machine's resources can deal, we can use a bash one-liner to expand the functionality of nmap beyond what it currently does.
That's really cool.
Yeah. So I used to work for Twitter years ago, and when this was written, my friend Paul that wrote this tool, him and I were doing mass scanning of the internet. This is before mass scan existed. We were trying to do this on the internet at large scale. And I would complain to Paul, I'm a terrible Python coder, like I don't know what I'm doing, please help.
I'm a terrible programmer as well.
So he wrote this tool called Tossa, and that's what it was designed to do, was you would feed it a gigantic, like /11, for example.
Yeah.
And it would slice that /11 up into 8,192 /24s, and then it would feed each one of those into a remote worker that had, like, this worker is allowed to run 10 copies of nmap.
Yeah.
So it would take 10 jobs off the queue. Then we'd have 30 workers or 50 workers or whatever, or scattered across the internet. So we'd have little scans coming from all over the place instead of one massive scan coming from one place.
Yeah.
And it turns out that you get a lot more rich results that way, because one host scanning the whole internet is one thing. Having like 50 VMs scanning this much of the internet, that's okay. You can probably get away with scanning a /24.
Yeah.
Especially if you're scanning like another country that has extradition laws that are favorable.
Yeah.
So it's a stopgap until the people that write either mass scan or nmap start to sort of work towards each other in terms of functionality and workflow.
Yeah.
But it works. So at the time, I was doing this on a LAN when I was at Twitter. Part of my job was to scan the entire corporate office, the internal network, where all the laptops and test machines like exist, to find out things like are developers installing things like Jenkins on their own machine and then taking it to like a coffee shop.
Right.
And Jenkins, the creds are root.
Yeah.
And like there's source code living on this machine.
Yeah,
like I had to help gauge the risk of that.
Yeah.
And it was part of my job to try to catch people that were being lax with security with the company's code. And we used this internally on a host on the network, and it was pushing 800 megabit a second out the gig interface, and it scanned a /12 in on all ports, a /12 on all 65,535 ports in what's from 10 to 2, so 5 hours?
Jeez.
10, 11,
Yeah.
12,
Well, that's
1.
not bad.
Yeah, 5 hours.
That's
So-
not bad at all.
Yeah, so 5 hours to scan the entire office. And then we took all that resulting XML and we dumped it into our SIM. And then what we could do is say, search for this MAC address.
Oh.
And we could see by MAC address, this person was in the office today and yesterday and the day before that, but not on the weekend, and maybe they took a day off or whatever. And then from that we can say, here's the port values, here's what open ports they had on their workstation day over day over day. Oh, here's a new one. Oh, they installed a thing. So it allowed us to basically action on that. So we had
really cool.
This turned into an automated thing. It was completely hands off. It would run every day from 10 to 2, and then it would. I
was going to ask what you use this for, and that's a great example.
It's very practical applications.
Yeah, it's very practical.
So the idea here, so like this started as a let's scan the internet for fun thing.
Yeah.
And it turned into like...
Don't all things start out like that, especially for hackers?
The good ones.
Like,
yeah,
ooh, this
totally.
is fun. What can I do with this?
Right.
Then you take a little step further, and then you just like, how far can I go without
Yeah.
getting in trouble?
And at some point, you do this several nights in a row, just like groggily, like the coffee has left my brain, it's 3 in the morning, I'm doing this thing. At some point, you're like, I have to get to a certain point. I have to reach a stopping point before I can put it down.
Yeah, of course.
And then you sleep on it, and then you wake up the next day, and you're like, wait, there's a cool new, I thought of a thing. So you do the thing, and you're like, oh my God. And then you tell some friends, and you're thinking down this way, and they're like, oh, well, what if you did this one other tweak over here? And then you just, you're like, I can use this for work.
Why did I do that the first
Oh my
place?
God.
Yeah, that's
so
cool.
suddenly, like, things just line up sometimes. It's great. But
that's awesome.
Yeah, so I mean, this is an endeavor to discover what's on the internet. I mean, this is like Indiana Jones style. We're swinging around in the jungle of the internet trying to find the weird animals that nobody's seen before. And believe me, there are some bizarre ones. I've done many, many talks over the years, that stuff I find on Shodan.
Yeah.
This is mechanically speaking, this is what Shodan is doing before the stuff goes into
before the pretty GUI.
the search engine. Yeah, exactly.
Yeah,
so I mean, you could ostensibly do this and then make your own Shodan. And I know organizations that have done that. They're like,
that's crazy.
HD Moore ran a thing called Sonar for a while, which was exactly this, and it was for tracking SSL certs and some other stuff.
Oh, that's cool. Wow, that's brilliant.
Yeah, so there's a bunch of cool stuff you can do. All you need is a bit of iron and a colo that's not the cloud, so you're not like violating a EULA.
Yep, of course.
And you're off to the races. Like if you're willing to spend, I don't know, anywhere between $100 and $200 a month for I mean, you have to have your own server before that, obviously.
Yeah,
but
yeah, of course.
you can get space in a shared rack, or you can buy a quarter cabinet from a data center, and then just buy a decent. You don't need a lot of.
That's cool.
You don't need a lot of CPU.
Yeah.
You don't need a lot of disk. You do need a bunch of RAM. The thing for this is you need lots of RAM and you need lots of network power. So if you have a 10 gig Ethernet card, that'll do you really well if the data center has 10 gig. But I can't wait to put my 10 gig card in this machine because these numbers will like
they'll just explode.
Hopefully, with one whole order of magnitude, I'll be able to do this 10 times faster. So instead of scanning, instead of scanning the whole internet in 2 hours and 11 minutes, what's a tenth of 131?
Not much. 20 minutes?
13.
13 minutes. Yeah, that sounds right.
Yeah.
We can math, really, with calculators.
Yeah. I need more coffee. But
I know,
so ideally, I mean, back in the napkin math, I'd be able to scan the entire internet on one port in 13 minutes.
That would make your job so much faster.
That would mean I could scan the entire internet during a segment.
Ooh, I feel like we should make this happen.
It's a thing. Paul,
very cool.
Paul and I did that on stage a couple times years ago. Paul McMillan, the guy who wrote Tossa,
Cool.
We did this joint research project where he did most of the coding, like 90% of it, coming up with a methodology for scanning the internet, finding hosts that had VNC open to the world, and then screenshotting them and returning the results.
Cool.
And one year, it was done live on. I think it was just Paul that year at TourCon. He did it live on stage. I loaned him my box, and he had several of his own.
Yeah.
And I think there were 6 or 7 in total.
Oh wow.
So the whole internet-wide scan on 4 ports or 3 ports, like the top 3 or 4 most used VNC ports, like 5900, 5901, and 5902. If I recall correctly, the initial scan took 8 minutes, and then the rest of the time was the post-processing for the screenshotters to go and take pictures of all the resulting hosts. Yeah, but that was just good fun because it was like live, right? We were watching the results come in, and the crowd was like, clicking on and
That's so cool, man.
Yeah, he opened it up so that people in the crowd could go to the UI, the web UI that was the gallery of the results and look for stuff. And people were shouting from the crowd, go to .8 or whatever, go to .12, look at here. And people were finding all sorts of ridiculous stuff.
That's amazing.
Yeah, it was fantastic.
That is very cool.
I have
so many stories. I love it.
It never ends. Well, this is my charge. Like,
of course.
This is how you change things from inside. You do stuff and you try to lead by example.
Well, this is a great example of leading by example. I think it's really cool, and I think it's a really interesting way to use NMap, and something that I never thought of, given that most of my experience with it has been pretty basic up till now. So that was very cool. I'm sure you have a lot more really interesting things you can do with the different tools. So this is going to be joining us on a future episode to do a little bit more on these concepts to build upon this. And we'll see him again next week for that. Where can people find you until then if they have any questions about this?
I'll be troublemaking on Twitter.
Troublemaking on Twitter. He's at Vis on Twitter, or you can find him over at phobos.io as well, which is your company. It's super cool. And of course, if you have any questions for us, or if you just want to comment, hit the comments below. Make sure to subscribe and go over to hak5.org to check out all the different products in the Hack Shop, as well as all the other shows that we do. So I'm going to go ahead and wrap it up here. Thank you so much again, Vis. Really appreciate it.
Happy to be here. Cheers. Thanks for having me.
Yeah, absolutely. And as we always say at the end of each and every single episode,
trust your technologist. Yeah.
Bloopers are going to be off the chain.
Oh no.
And
this is all going to the internet, isn't it?
It's all going on the